When you think of the internet, you probably picture this single, giant, floaty cloud, right? Well, the reality is something way more interesting and, honestly, way cooler. Today, we're going to pull back the curtain and show you the real architecture of the internet. Let's get into it. So, I'll just ask you straight up, is the internet one big thing? The answer is a huge, resounding no. It's actually a massive collection of thousands of totally independent networks that all agree to talk to each other. And getting your head around that one fact is the key to understanding, well, everything. So here's our game plan for this explainer. We're going to start with the basic building blocks, the networks themselves. Then we'll look at the special language they use to communicate. After that, we'll dive into the business deals that control how data moves, see the physical places where networks meet, and finally, we'll track a single packet on its wild journey across the globe. All right, first things first. Let's completely shatter that idea of the cloud. The internet isn't one network. It's a network of networks. And each of these individual networks has its own special name. And that name is an autonomous system, or AS for short. The easiest way to think of an AS is like a single big digital kingdom on the internet. It has its own rules, its own administration. Your home ISP is part of one. Google runs a bunch of them, so do big universities. These are the Lego bricks of the internet. So who's running these things? Well, it's a whole mix of players. You've got your giant ISPs, the cloud companies like Google, which runs AS15169, and content delivery networks like Cloudflare, which uses AS13335. Every single one is its own distinct territory on the internet, and each gets its own unique AS number to identify it. Okay, so if the internet is made up of thousands of these separate digital kingdoms, how in the world do they all agree to talk to each other, right? They need a shared language, some kind of universal protocol. This right here is the fundamental problem that had to be solved. It's called inter-domain routing. That's routing between these different AS domains. Every time you send an email or stream a video, your data has to cross from one of these kingdoms to another, seamlessly. And trust me, that doesn't just happen by magic. It takes a very, very special protocol. And that protocol is BGP, the Border Gateway Protocol. You can literally think of it as the official postal service for the entire internet. While other little protocols are busy directing traffic inside a single network, BGP is the only one that does the heavy lifting of figuring out the paths between all these different networks all over the world. Now, here's what's so wild about BGP. It's not trying to find the shortest or the fastest path. Nope. It's built for massive global scale, and most importantly, it's all about policy. And those policies are usually all about business deals, which gives the network owners incredible control over where their data goes. And this is the absolute key. BGP doesn't think about tiny little routers. It thinks in terms of entire autonomous systems. So a route, in BGP world, is just a sequence of these ASs. It's the list of kingdoms your data will pass through, say, from Cloudflare, through a big carrier like Level 3, to finally get to Google. And that sequence of numbers? That's called the AS path. And that idea of policy is the perfect lead-in to our next topic. Because those BGP policies we just mentioned, they're not just technical settings. They are completely tied to business relationships and the economics of how these giant networks are wired together. Money literally shapes the path your data takes. You see, the internet has this pretty clear hierarchy, kind of like a pyramid. At the very, very top, you have the Tier 1 networks. These are the massive global backbones. They can reach every other part of the internet without paying a dime. Below them, you've got Tier 2 networks, who have to pay the Tier 1s for access. And way down at the bottom is your local Tier 3 ISP, who pays a Tier 2 to get you online. It's all a big cascade of payments. So these financial setups really boil down to two main kinds of deals. First, there's transit. This is a simple customer relationship. A smaller network pays a bigger network for a connection to the whole internet. But then you have peering. This is totally different. It's usually a handshake agreement between two networks of about the same size. They agree to swap traffic between their customers for free because, hey, it helps them both out. Okay, so we've got the networks, we've got the business deals, but where does the rubber actually meet the road? I mean, this isn't all just happening in the ether. Let's talk about the actual physical buildings where the internet comes together. This all happens at places called Internet Exchange Points, or IXPs. The best way to picture an IXP is like a giant digital marketplace or a central post office. It's a physical building, usually a massive data center, where hundreds of different networks literally run fiber optic cables and plug their routers into one giant shared network switch so they can exchange data directly. So, why would they bother doing this? Oh, the benefits are huge. By plugging in directly at an IXP, networks can shoot data to each other way faster, which cuts down on lag. And it all comes back to the money. Instead of paying a fortune to a big transit provider, they can just swap traffic for free with their peering partners at the IXP. It saves them a ton of cash. And this brings us right back to BGP. Remember how we said it's all about policy? Well, this is where that policy becomes absolutely crucial. When a network has multiple options, maybe some expensive paid transit links and some free peering links at an IXP, it needs a way to choose the best path. BGP is the brain that makes that decision. And it makes its decision by running down a very specific checklist. First, it'll check something called local preference. That's just a number the network admin sets to say, hey, I prefer this cheaper peering path. If those are tied, it'll look at the AS path length. Shorter is usually better. It can even use other tricks like MED to try and influence how other networks send traffic back to it. It's a really sophisticated, policy-driven decision process. Okay, deep breath. We now have all the pieces of the puzzle: autonomous systems, BGP, the economic tiers, and the physical IXPs. So now for the really fun part. Let's put it all together and follow one tiny data packet on its epic journey across the planet. When you zoom all the way out, the internet's global map looks like this: an incredible, sprawling, beautiful web. And it might look like pure chaos, but now you know the secrets. You know there's a hidden structure in there, formed by that tiered hierarchy, the dense clusters of peering and IXPs, and the whole thing is governed by the logic of BGP. So let's trace the path. A user in Turkey clicks a link. The packet's first hop is to their local Tier 3 ISP. That little ISP has no idea how to get to California, so it sends the packet upstream to the Tier 2 network it pays for transit. That Tier 2 then hands it off to a massive global Tier 1 carrier. The packet zips across the Atlantic Ocean on that Tier 1 backbone, lands in the US, and is finally handed off to Google's own network, most likely through a free peering connection at a huge IXP. What this really is a beautiful symphony of systems. BGP is making those smart policy decisions at every single hop. The economic deals, transit and peering, define what paths are even possible. And the physical buildings, the IXPs, make those connections fast and cheap. All of it has to work together perfectly to create that seamless experience we just call the internet. You see, this entire global routing system that we've just described is built fundamentally on trust. Tens of thousands of independent networks have to trust that the routing information they get from each other is accurate and honest. But that trust can be broken. Bad actors can pull off something called a BGP hijack, where they lie and announce routes they don't own, sucking in massive amounts of the world's internet traffic, which leaves us with a really critical question. In a system so completely dependent on cooperation, what happens when that trust breaks down?